Yeah.
Okay.
Okay. Uh, Good evening, lecturers. Today we're gonna to present our topic. Our topic is forest fire monitoring and early alert system. So we are from group 41. I got our team got four members. The first one is Liu Kaishen, second one is NK Sian, and the third is Tan Junli, and me is Chong Hao Nan. So now I will go to the introduction. The problem statement is the forest fire have become increasingly frequent and intense due to the climate change, deforestation, and human activities. These fires not only endanger the ecosystem and biodiversity but also pose a serious threat to the human life and property. However, many remote forest areas lack real-time monitoring systems that can provide immediate alerts to the authorities. So for our project objective is to design and implement a forest fire monitoring and early alert system using the microprocessor-based technology. Our main objective is to develop a real-time system that can detect early signs of forest fire and automatically issues alerts to the relevant parties. Uh, so for the relevance to the SDG 13, this project directly contribute to the Sustainable Development Goal 13 by enhancing the climate resilience and supporting the mitigation strategies. The second one is early detection of forest fire, reduce the carbon emission from uncontrolled burns, help protect natural carbon sink, and allow the authorities to respond swiftly for minimizing the environmental impact. Now I pass next teammate to the schematic diagram.
Yeah. Hello, everyone. So I'm now going to present about the schematic diagram. So as you guys can see, this is our schematic diagram lah. You guys can take a look. So we use some critical components. So I will going to explain about the critical components that we involve, which is we got the 8085 microprocessor, the 8255 programmable peri, per, peripheral interface, which is PPI, the 74LS373 address latch, the temperature sensor, smoke sensor, LED indicators, which got three lights, buzzer, and the shut off button, and the address. I'm going to explain about these components. Next slide. So the first thing is the main one lah, which is the 8085 microprocessor, and it acts as the central processing unit CPU of the system, which is CPU of the system, and it continuous monitor sensor inputs through I/O ports and make decisions based on the program logic, and it controls output alerts and handle manual shutdown input. And the second thing is 8255 programmable peripheral interface, which is PPI, and it serves as I/O expansion interface, enable the microprocessor to communicate with multiple input and output device simultaneously, and it is configured in mode 0. So it got the input of port A and port B and the output of port C. So the next thing is we got is the address latch. So since the X0X5 multiplex is its lower address and data bus is 80 until 87, this address latch is used to latch the lower byte of the address during address decoding. And then this ensures that stable addressing of the 8255 during I/O operations. So the next thing is we got the input, which is the temperature sensor, which connect to the port A. So this sensor outputs a value representing ambient temperature, which is compared in the program to determine the potential fire condition. And the next thing is smoke sensor, which is the second input. So which connect to the port B, and it provides digital or analog signals indicating the presence of smoke particles, and the height readings indicate a potential fire. The next thing is the LED indicators, which got the three color of light, which green, yellow, and red, which represent normal conditions. And the second one is the warning condition, which is when the temperature is high and when the very dangerous condition, which is the activates when the smoke is detected. So the next thing we got is the buzzer. So it produces audible alarm in both danger and warning condition. It is toggled when time delays and simulate pulse alerts, and this is outputs. And the next thing is shut off buttons, which connect to the port C, the fault of the port C. So the push button is connected to port C and allow the manual reset or shutdown of the alert system. When press, it sends a logic low zero signal, which is the microprocessor to silence alarms and resume monitoring. And the last thing we got address decoder, which if the multiple devices are used or address range management is needed, a decoder such as a 74LS138 can be used to generate the chip select signal for the 8255 based on the high order address lines A8 until A15. So this is my presenter. So I will pass it to the next person, Kaishin, to explain about the flowchart for the coding.
Okay, thank you, Christian. So I will be introduce the flowchart now, and just as this flowchart is about our assembly coding. So the first thing we would like to set up the 8255 PPI. If I so initialize, we set up the three port of it, port A, port B, and port C. So we set it as an input and output. But what is special is that the port C we have an both input and output because we're going to set up the 4 from PC0 to PC4 to indicate each like LED buzzer and so on. Another one is that we want to make an output for the shutdown system. Yeah. And so the first thing, as you can see from there, so the first is initialization of the P8255 PPI, which would be like connected to the 8085 microchip. And the first thing, we will check first whether the shutter button is pressed or can be function well. So when it's yes, then you will turn off all the output, which to set the accumulator. You will load 00H into the accumulator, and you will give a delay of 1 second because you want to give the reaction time to the machines, and you will go back to the starting point, which is our main program. The next thing is that we will go to the warning loop. The first thing, so the first is the port A is that you want to for the temperature sensor. So when the temperature sense that the temperature is equal or greater than 45 degrees Celsius, and the buzzer will activate it, and the warning LED will also activate it, which is the first bit and the second bit. And of course, we delay by 500 milliseconds. So the most interesting part is that we actually have a different delay time for each condition. Let's say we have 3 conditions: normal condition, danger, and also warning conditions. So the warning condition, the delay time is much longer, which is 500 milliseconds, equal to 0.5 seconds, which will periodically using the buzzer to ring like we ring it periodically because the buzzer we need to have to avoid so-called fatigue times in order to give a good maintenance for the buzzer. And of course, it will increase the lifespan of it. And the next thing is that we also add each shutdown system. We also add the shutdown system for each of the conditions. It's just in case that we will loop it infinity until the temperature or something. We make the optimized thing, and then we try to shut it down. And of course, after that, we also will deactivate the buzzer because we want to, just like I say, that we want to make it buzz like ringing periodically, so it will shut down periodically and delay and continue until entering an infinity loop. And the next thing is that when the warning loop, when temperature degree Celsius is not greater than 45 degrees, which is less than 45 degrees Celsius, and we will again go into the smoke test. Yeah, when the smoke test is in port B site. And when the smoke test is achieved like 200, and it will also activate danger loop, which also going in. And danger loop is a little special. We're using a shorter delay time because to give a important signal that we want to ensure people to know that this is a danger signal as compared to the warning signal. So it will like ring faster like the buzzer. So because the delay time is just 0.2 second, 0.2 second, yeah. And also the shutdown system is just in case that when the scenes is already soft, or the smoke level is already decreased or temperature decreased, and so on. And also we will also deactivate the buzzer just like before because we want to make it buzz periodically. And the last condition is that it's a normal operation, which means that both of the condition above is not achieved, is not in the warning zone, is not in the danger zone, and we'll go to the normal operations, which means it's our green light. When you run a normal operation, and then it will go back to the main program, which means it will loop again, loop until it found that there is either a warning condition or a danger condition. And that's it for all our assembly programming. and for project. And I will pass the next person, Tan Jin Lee.
Okay, thanks, Kashan. And now I'm going to talk about the advantages. So, for the simplicity and operational efficiency, the system is designed with ease of deployment and operation in mind. Okay, so it uses low cost and readily available sensor and a microprocessor-based controller, making it simple to assemble, program, and maintain all the system. So, and the second one for the simplicity is its real-time alert mechanism ensures swift communication with minimal human intervention, enabling authorities to act quickly and effectively during the early stage of a fire. So then for the innovative integration of multi-parameter sensing, so unlike the conventional system that rely on a single indicator, this project combines multiples of environmental parameters such as temperature, smoke, and gas levels for more accurate fire detection. Then the multi-sensor approach significantly reduces false alarms and enhance the system reliability. Furthermore, it's adaptable for integration with wireless communication modules, supports remote monitoring and scalability, making it suitable for large or inaccessible forest areas. Okay, so this is all the advantages. And now I'm going to do some conclusion for our project. So the forest fire monitoring and early alert system represent a significant advancement in wildfire management by combining temperature, smoke, and gas sensing into a single cohesive platform. Okay, by facilitating rapid data-driven response and minimizing uncontrolled burn events, our solution not only enhance forest protection but also contributes directly to SDG 13, which is climate action through reduction of carbon emission and preservation of critical carbon sinks. Okay, so for the future works, I will pass to Chong Hao Nan to finish it.
Okay, thanks, Najuli. So for the future works, I got two. The first one is the AI-driven risk prediction. So this is about to develop the machine learning models that analyze the historical sensor and the weather data to forecast the high-risk fire zone and optimize the sensor placement. So for the second one is the cloud dashboard and mobile apps. This is to create a user-friendly web dashboard and the smartphone app for the real-time alert visualization, historical trend analysis, and rapid response coordination. The next for the reference, here the tree is our reference for this the project. Next. Okay, thank you. That's all from us.
Okay, thank you.